Hi everyone, welcome back to my channel Takniki Gyan Guru. I'm back with another session on AI ML and generative AI. In this video, we'll create a traffic light classification app using Node.js and React.js. We'll cover everything from setting up our development environment to building both the backend and frontend, and finally connecting them together. So before we get into our today's session, I would like to request please like, share and subscribe, and don't hesitate to give your feedback on the comment section. If you have any query or questions, please write down in the comment section. So let's get started. So first of all, we'll talk about the React.js. We will use React.js as a front end where in this React.js, we will have the front-end code. We will use Azure for HTTP request. This will be used for send a API call to the backend. And React spinners will be used to handle our loading images. So when a API call is raised, then until we get the response from the backend, the React spinners will use to show you a loading image. And once the respond, we have the response from the server, the loading image will be gone and display the result. So we'll see the code of React.js as a front end. Then we'll talk about the Node.js that will work as a backend. In the Node.js, we'll use Express as a server. So Node.js will work as a server, backend server. Multer will be used for handling the upload files. So we have to save all the images into one of our folders so that uploading image will be handled by the multer. TensorFlow including the COCO-SSD will handle our image classification where we will create our models, the COCO-SSD models, and will pass our know mm, image into the model, and then it will predict whether the image is traffic light image or not. So that will be use this model we use to classify our image, and then we will have our own code for see the image, which light is on, red, green or yellow. So that logic we'll discuss later in the code. So once we have the React as a front end and back end already, then a user can access the front end, and the front end will um, have a API call from the backend server where it will have all these response whether the image uploaded images, um, traffic light image, or and what are the predicted percentage, right? And that will be respond back to the React.js and end user can see. And then we'll talk about the prerequisites. So to create this application, what we required as a development environment, right? So for that we required Python. In I'm using in Windows. For Windows you have to install the Python, and this should be accessible in the environment path variable, right? And then we have to install build tool, desktop development with C sharp. If you already have a Visual Studio installed on your system, then in that case it is not required, because by default it is. If you have already checked this one, then it will be installed. Otherwise you have to install this is the prerequisites for the TensorFlow, right? And another prerequisites, it is not prerequisites, but I have the latest version of Node, right? 21. But for the TensorFlow, it is very compatible with Node 14 and 16. So because of we have to use only the Node 16, that is very comfortable with TensorFlow, right? So we will use Node. We will have multiple Node version in my system. So to use selected version, right? So I will use a Node 16. So first of all, I have to install Node 16 and then use the Node 16 because I have already installed Node 21. So I'll show you how we can do this. So once we have the Node 16, apart from the TensorFlow in Node.js, we also use the Sharp library that will Sharp will use to compress our or resize our images, right? So to resize your image, the Sharp is useful. So why we are resize, we'll talk about later. So this is done. So we understood the prerequisites and the front end and the back end and how it works. So once we will go through the code, then we'll understand more how we can implement this traffic light classification. So this is done. Now we'll go for the demo. Let's go and check it out. Now let's understand the prerequisites. First of all, we should have installed the Python. So let's open one command prompt and see Python version. Python is already installed, Python 3.12.2, right? So I don't need to install the Python. Let's see Node version. See 21, right? So this 21 Node 21 version is not compatible with TensorFlow, so I will downgrade this one using nvm. So downgrade to Node 16. Okay, so let's understand the prerequisites. First of all, Python is installed. Install Visual Studio build tool. So https with colon double slash visual studio dot microsoft dot com slash visual hyphen cpp hyphen build hyphen tools. So this tool is required. Let's open in browser. I'm just putting this one. Okay, so you can see visual studio dot microsoft dot com slash visual hyphen cpp hyphen build hyphen tools, and you can see download build tool. You have to click this. It will start downloading build tool and you can directly click here. It will start. I have already installed it. I'm just going to show you how to install it, right? So it will ask you for, okay, you can say yes. You can say continue. So it will ask for to upgrade Visual Studio tool for because it is already installed. That's why it is asking for me. I would say upgrade, and it will start upgrading the tool. It is asking me for update, right? But for your case, it will ask you to select few options, right? So you have to select this one, right? show you. C++ build tool, right? Desktop installation. So that is, you have to choose and then install it. So I'm just pausing this because it will take a lot of time, right? So I don't want to uninstall it again. I'm just pausing it, right? For your case, you just need to select, and then you need to select and then install it. If you have any question query, please write down in the comment section. I will definitely respond back to you. Now we will go and see the other options. Click on now NVM, right? So we have already seen the .NET. This is first of all when the Visual Studio downloaded, and during the installation, as I said, select desktop development with C sharp. So it will show you some options. You have to select this one. I have I have already installed it. That's why it is not asking. It is asking if to update. So when I am going to update, it is just uninstalling and installing it again in the newer version. So you don't need to do that. Just install this one only. Still, if you have any question query, please ask. I'll help you or guide you to resolve or fix the issues. So let's go and website https :/github.com core y butler /nvm -windows /release. So copy this and go to the browser, and I'm just putting this and go down. Okay, you can see nvm no installer zip. You can download nvm setup directly, or if you want to download as a zip, you can download it. I'm going to download this directly from here, setup, and let's see if okay, and I'm just going to run it from here. Okay, it is asking me, do you want to allow this app make changes? Okay, I'm saying okay, yes, and license agreement, I'm accepting this agreement. So while default directory, I'm just choosing default directory, you and say yes and install. Node 21 is already installed. Do you want to NVM to control this version? You say yes and okay, right? So finish. Now let's go to the command prompt and see nvm version. So nvm is already installed. Now let's say sometime if this not works, you can close the command prompt and reopen new command prompt. That will work. And nvm install 16. So it will install a new version, the old version of 16, node version of 16. Now nvn select 16, and we sorry, the nvm use, not select, nvm use 16. So this will switch or downgrade. It will ask for your approval. Say yes. Now if I say node version, now you can see the node version is 16. So I just downgraded 21 to node 16. Once your application is ready, you can upgrade using the ambient. You can just use nvm use 21. So it will upgrade, right? So if you want to have another version, you can switch. First of all, you have to install nvm install the version, and then nvm use the version. Now this is done. So we have installed this nvm and all, and we have already switched. Now we are in the Visual Studio. You can select any folder. Inside the this folder will code, right? So let's create an open a new terminal. Correct. Inside this folder we will have different folder. First of all, we'll create a Node.js application. Let's say Node version 16, right? So let's create mkdir server, saying the server folder, and cd server. Now this is a new folder created, and then we will create a mm, Node.js application. First of all, let's say npm init by, to initialize the project, and then we will create a server file. Okay, in the server we can see the package.json is created, right? Now let's create another file over here. It says server.js, and I'm just putting my code over here. We'll discuss it later, right? uh, and this is done. Also, what we need to do is we need to create another folder called uploads, because mk, sorry, here mk inside the server, right? Folder mkdir uploads. So uploads folder is required because all these files, images will be saved into this folder. Correct. Now we need to install the express as we discussed earlier. Let me see. We are installing express, multer, course, TensorFlow, TFJS nodes, and TensorFlow model, COCO-SSD, and Sharp, and JPEG.js. As we discussed, right, Sharp latest version won't, is not compatible with this TensorFlow and Node.js version. So we have to choose this for the 16 Sharp 0.28.3. This version is compatible with Node 16. So I just downgraded the Sharp as well because of this. For code decode the JPG image, we are using the JPG.js. So this will install all our requirements, right, for the Node.js, like Express, Multer. We have already discussed course, TensorFlow, and the COCO-SSD, Sharp, and JPEG. Oh, it is giving me error. Understood the system Windows NT this while falling to build. Child process, okay. So we have stopped the pause this one, right? If you can see, I just pause Visual Studio installer. So some of the build tool is uninstalled, right? So let us modify. I'll show you what we have done because the build tool is not installed correctly. Understood. This issue is basically we have uninstalled the Visual Studio build tool, right? So we have just paused this, right? So I'll show you. Just modify. When you download and click on install, then this option will be available, right? So I just paused and modify, then we'll see what we have selected to install the build tool. There are multiple options, so we need to select only one option here. So because I have already installed it and go for update, because of that this issue comes, right? Now you can see the multiple option over here. I have selected the desktop development with C++, only this one. So when I just update, it get uninstall these things. Because of this it is not working. So I just select it again and modify. So it will take some time. Once it is done, then I'll come back and see. Now you can see the build tool is installed perfectly. Now we'll go and uh, go to the Visual Studio Code and run the same command again. If this doesn't work, then definitely we'll go. Yeah, let let us run this command again. Okay, I'm running it again and see if this works. Yeah, it is working fine now. uh, it means the Node.js version is install all the prerequisites. We have already discussed the prerequisites, correct? Like the Express, Multer, Course, TensorFlow, COCO-SSD, Sharp, and JPEG. So these prerequisites already installed. That means our server is ready now. Now we'll create a client application. Let's say we are here server, right? Let's move to the root directory. Um Traffic light classification, right? Inside the traffic light classification we have the server. Now let's create a project here. Npx create react app client. So this will create a react app inside the traffic light classification, right? So let's run this. We'll create another folder with a React.js application. You can see the client. So now React.js application is created. Go to the client folder. Now we have to install the prerequisites for the React.js application. Npm install Agios and React spinners. These two is required in the React.js application. So okay, this is done. Now click on the client and source. Here we will update the code in app.js. This is the default code. So I will copy the code. Yes, Control A, Control V. So I just paste my code over here. We'll understand later. And also the app.css. So we'll understand the code one by one. Go to the server.js. Let's understand this one. So first of all, we will have all these dependencies: Express, Multer, Course, TensorFlow, including COCO-SSD, files, file streaming, and path, sharp, and GPG. These are the required libraries we need to import. We'll run this application on 5000 port Node.js. You can change according to your requirement, right? And then we will use Course, Express, right, and uploads. Static this one. So first of all, we'll create a storage. The name will be for uploads. We have the upload folder, this one, right? So this will use a create a storage with the file name, right? The path and date values. Now um, we'll have the upload storage. We'll create another variable upload that has the storage of this filter storage. Create another object, multer object with this storage, and then we'll create a post method. This method will be called by our front end slash upload. This is the our website slash upload, uh, on this Node.js application, right? It will call through this the Node.js application URL slash upload, and then our uploaded single image, whatever upload will have, that will you use as a single image, right? So that image will be stored into this folder, right? And we'll see if the file is if there is no file, then we'll return no file uploaded. Otherwise it will go to the try catch block, where we'll get the path of the file inside the upload, and then we will get the buffer, right? How we will get the file stream, read file sync image path of the image, and we will convert it to buffer using the file stream. Then this buffer image will use here to resize using the sharp, right? And we have the two object data and info. In the data, the buffer image data will be there, and the info will have the width, height, and channel. So how we'll do that? In these two variable, we have the update sharp image buffer, right? This image we will pass, right? And then we will resize 640 width and 480 height. Raw is basically it will return the raw pixel based image here as a buffer, right? So this data info will be used here to decode our image. First of all, the decode image object where we have the data, we have the width, info dot width, height, info dot the height, and channel, info dot channel. So two variable from this variable will create another object, and decode image. We are just decoding the image, and then we'll convert this decode image to unit 8 array. This unit 8 array will take the decode image data, decode image height, width, and channel, right? It will convert into a unit 8 array, and then we will convert as a image tensor. So how image tensor will be converted, like tf.tensor 3d, it will convert into three-dimensional tensor, right? And this tensor image will be used in the model. So first of all, we'll create a COCO-SSD load model here, right? Using this COCO-SSD, we'll create a model. Using this model, we'll detect this image, right? We'll pass this image and we'll detect as you right, and we'll get an object to predict here. So first of all, we'll detect, and then this prediction will be used here, right? Prediction would filter. So from here we will filter whether this image is traffic light or not, right? So once it is filtered, you know the traffic light, if it is traffic light, the details will be here inside the traffic light, right? This one. And then now we will have the promise dot all, where we will have the traffic prediction, this one, traffic prediction dot map sync pred, right? And we will create bounded box. This is basically to uh, coordinate xy coordinates, and also the width and height will be there with this one, right? And then we will then lastly we will predict this image, means the prediction of this image means what percentage it is matching, right? So then image tensor dot slice math round bbox 1, math round 0, math round this one 2, right? Correct. This image dot tensor dot slice will slice this whole image into different uh, slice the different boxes, right? So that it will it will easy for us to you know classify this image, right? How to classify? We will have to classify through this um, you know it will return different colors, right? First of all, it is prediction. We will first of all, prediction is there already. I'll show you this prediction, this spread value, right? This spread value is our prediction, how many percentages there, right? So once the prediction is there, then we have to prediction we have already predicted, but we have to see which light is on. So for that, first of all, we'll slice this image and as a light region. So we'll get the reason of the light, the image, and then we will resize it again, and then we'll get the color, RGB color, red, green and blue. And then we will see, based on their values, we can predict it is green is on, or red is on, or yellow is on, right? So this light reason we will use for predict which light is on. So how we will predict? We will call this method, and we are passing light reason and prediction. Prediction is, it is not required, I just passed it, so we can remove it. And we will return red and color. Two things will, the color object will be returned and the prediction will be returned here, right? So based on prediction and color, will display the message, right? So let's see, let's understand. This is the error. If there was an error, then we will return the error here, and then we will understand this classify traffic light color. See, we will pass tensor and the prediction. So again we will resize the tensor 10 by 10 by 10 pixel. This is the pixel, right? Why we are resizing it? Should be smaller, so that it should not have very complexity, right? So we will just minimize the complexity to uh, resize very small image. So first of all, image resize this tensor, then we will get the mean color of it. So resize tensor to mean 0 and mean 0. This will mean color dot erasing. This will return the mean color R, G, and B, right? The image colors, right? The value of the red, G, and B. So we will display the R value, G value, and B value. So based on this RGB color value, we will predict whether it is light is red is on, or green is on, or yellow is on. First of all, red, this is not required. You can disable it. A blue threshold. So this we use only for the yellow color, right? So we are assuming that this threshold, this logic is based on my understanding, right? This logic should be changed. So maybe based on different images, you can change your threshold and this code. So based on my image, I have just given. So we will understand, right? This threshold why I have used is for blue threshold, right? So blue threshold should be always 70, less than 70, right? So how we can predict? First of all, we will see the red one, right? Yellow will return later. So when the red value is greater than green and blue, then it should be red always. Whenever we'll see the red value of red is greater than value of green or value of blue, then it will always be red. And if the value of green is greater than red and also greater than blue, then the light would be green. So green should be on, right? And now we have predict the red and green. Yellow, red is greater than green, and green is greater than blue. So this will be again red is greater than this, right? So this will be match here also. But what we want is, if red is greater than G and green is greater than B, also the blue is less than 70, then in that case this should be a blue, because in any image it will have three RGB colors: red, green, and blue. Based on these colors, we have to predict which color is on, right? Which light is on. So this is the logic. It is not fixed. We can change as per our requirement, right? So we will get the mean color of this image RGB, and based on this mean color we have to put our logic. This is not fixed, you have to change as per your requirement. If it is not understand, then definitely you can ask the, again we will understand, will get the RGB values, right? 100, 80, whatever values it will return from the mean color, and then we'll match if red color is greater than green color and blue color, then and the blue color is less than 70, then it should be yellow. Else if red color is greater than green, and red color is greater than blue, so red color is greater than blue and green, then it always be red color is on. And if green color is greater than R, means red color, and green color is also greater than the blue color, means green color is greater than um, blue color and red color, then it should be green. And if does not match anything, then it will return unknown, right? And this application will be listening and um, 5000 port, right? This is understood. So this is the basic code for TensorFlow and COCO model, right? Based on this, we will first of all identify, and if you can see here, first of all in the COCO model, it will identify the images traffic light image, right here. It will, if the image is traffic light image, then we will see which color is on. This logic is basically which color is on. This logic is basically very simple logic. It will be very complex based on the requirement, based on the images, right? Now let's go to the client. In the client section we'll understand the app.js. Again we are importing the ASIOS states and the React snippers. It is a clip loader, right? Clip loader is which is basically loading image, loader image will be there. Now f function, we have state like image, prediction and loading. Three states we have here. Handle file change, whenever we are uploading new file, then it will set the image here, right? The image. And set prediction, nothing, whenever we are changing. And handle submit, whenever we are click on submit, right, then this method will be run. First of all it will get the form data, and image will be with the form data. Now that image is uploaded, the image file I'll show you later. And set loading, this set loading will run the loader, this one, right? Loader means the started, right? Then the React.js will go and you know call the post method agios.post the HTTP request, right? Localhost 5000 upload. This is the upload, right? You can see in our server we have the post method upload, right? And we are calling this agios.post will post form data. It will have the image, right? Header is this multi-part form data. And here we are saying prediction response data, so we'll a response data, whatever response we'll get from here, will set into the set prediction, right? Set prediction is another state, the session value. Set prediction, the handle file is blank, right? Nothing. But when we are having any response from the server, backend server, it will you know put our response data into the set prediction. And if any error, then it will show you the error. Set loading false, once the this process is done, the loader will be disabled or this will not be visible. Now we'll understand the UI, right? First of all, we have the container. First of all, we'll show you traffic light classification and the form submit. Form, we have the file, image, and the submit button. Input, first of all, we have the input button where we have to upload a image, and another button we have to submit this button, upload and classify. When we click on the upload and submit button, this button will call this method handle submit, right? And this input type file images, this will call handle file change. Whenever you are uploading another image, this will call this file uploading. It will set your image into your form, right? And these two things, first of all, you will see the this message, and then two button. One is for uploading the image and another one for submit the image. And after this, if you are uploading image, then it will show you image, right? Let's say the image, and then create image URL, image or traffic light image. So it will show you whatever image you are uploading. It will show you below to this button. The image will be shows here, and then when you are click on the submit button, upload and classify button you click, then the loader will work, and it will the clip loader, right? This clip loader will on based on your loading value, right? If it is true, then it will show you this one loader. It will show you a loader button, means round and round. It will show once it is run, and it will display a message loading, right? So the and last one is the prediction. So if the prediction dot length is greater than 0, and then it will show you this message prediction. Inside the prediction we will say the detect a prediction color, right? Here detect a green color, red color traffic light with a confidence of prediction dot score into 100. And to fix it, that means it will give me always it comes like 10.88 or 0.75. So to mitigate that, we'll uh, multiply by 100, and then we will remove all the decimal values. Correct, this is understood. And we have applied some css to for this. You can see here uh, logo. This is the logo spin and container. Sorry, this is the container form, image container, image, the image size whatever you want. So I want, let me, if it is not, then a loading container and prediction container. Different containers we have prediction item, right? So you can see here prediction container, prediction item. This is the prediction item, this is the whole prediction container, this is the loading container. So different boxes we have, and these different boxes have different images, uh, style sheet, right? So we'll understood the code. If you have any query, questions, or any doubts, just you know put your doubts on the comment section. I'll get back to you. Now we will run this and we'll see. So you will not run from here. You can directly go and run from here, right? Start with, right? So I don't want to run from here. I'll go and go and open a command prompt, two command prompt, one command prompt for the React.js and backend as the Node.js. This is the backend server and the client React.js, right? So we'll go um, and open a two command prompt and see whether it is working or not, right? I'm just opening one. First of all, I'm in the same folder. Let's dir this client and server. Let's move to the client here. Server, okay, cd server, right? And another command prompt. I will open another command prompt, cd client, okay, cd server cls. This is the server and this is the client cls. So let's go run the Node.js application first. I'll say you can also open two Visual Studio Code and run one in the React.js and Node.js also. You can do as per your requirement. You can do. I'm just opening this on the command prompt and then see whether it is working or not. So in the server side, in this folder location, I have my if you can see server, I have the Node.js application, and the client, I have the React.js application, right? So let's move to the server. So now let's run this code using sorry, node space server.js. Enter. Okay, now you can see server is running on 5000 port. Let's move to the another this one client, right? Client. Now in the client we have the React.js application. Now here npm start and run this. It is still showing the previous version, so I think we haven't saved our code. So let's go to the app.js, control S, and CSS also control S. Go and refresh it. Yeah, now it is coming. So my system is little slow, so that's why it's taking little time. Now you can see the message traffic light classification. You can choose your image over here. I have some of the image. I will test those images. See, I have 6 images: two green, two red, and yellow. I will test everyone, all the images. So first image is green. If I upload and classify, click on upload and classify, I can't see the message. You can see the loader is here, and you can see detect a green traffic light with a confidence of 96.49. Let me change a little bit over here. Top margin 10 and image height. Let's do it 400 and run it again and choose the file. Yeah, so you can see images here. Green light is on. If I upload and classify, Then you can see detect a green traffic light with a confidence of 96.49. If I choose another type of green light like this one and upload this, see detect a green traffic light with confidence of 89.08%. Now choose another, let's say red, upload, detect a red traffic light with a confidence of 94%. Another red, okay, load image. Yeah, it is again giving the correct detect a red traffic light with a confidence of 77. Let's say yellow, upload and classify. Detected a yellow traffic light with confidence of 86.29. Let's choose another, this one, yellow. Detect a yellow traffic light with confidence of 76.76. So these are the images I have uploaded. It may not work for other images, maybe because of some different, the logic I have put into here. It may change based on different RGB colors. So these kind of AIML, it is very basic code we have given, but when we are creating a AIML traffic image classification, this is one of the basic code, right? It will be better if we go and do coding, create our own model, right? Just we have created in our flower recognition application. Similarly, we can go and create ML.NET image classification model. We should have our own image, and based our own image, we can classify, right? So that will be more better. You have your own control, right? How um, you have more control over your own code, also your images, correct? So how we can do, you can just create .NET image classification model, and then you can have a HTTP request, or API call from ML.NET or .NET Core to your Node.js or React.js application, and you can showcase this similar, right? So we have done with this demo. If you have any question queries, please write down into the comment box. I will definitely guide you. This kind of traffic light classification is very useful. There are a lot of use cases here. So suppose if we are implementing this into the mobile app, if someone is going and the this application is on, and based on your distance with the traffic light, and it will predict that you cannot, if you are not slow down your car or whatever vehicle, you will break the traffic light, right? You can, so for that, this kind of application will help you to either alert you to stop, or make your vehicle slow so that you can stop at the point of the traffic light. Or if it is green, you can you know pass through this red light, then it will also give you some voiceover on this. So this kind of application very useful. So done. Let's move to this slide now. Now we are done with this demo. Feel free to leave any question or comment in the comment section below, and I will get back to you as soon as possible. If your question is common issue that other might benefit from it, I will consider creating a dedicated video to address it. Your feedback and engagement are greatly appreciated. We have reached the end of our presentation. Thank you for watching, and I hope you found it helpful. Have a fantastic day. Take care and goodbye.